Hello friends, this is Partha sir. Considering the recent trend of the IIT JEE, NEET as well as AIMS and many other medical as well as engineering competitive exams, we have seen that physics always plays a very critical and important role. Now today I am going to discuss one of the important area, that is the wave mechanics. Now wave mechanics, there are certain percentage of problem which mainly comes associated with the string as well as sometimes it comes with the stationary as well as mechanical waves. Now here in the particular problem, it is given that a string of mass m and length l is hanging from a particular ceiling as shown in the figure. So this figure which was given here, that I have mentioned in the figure 1, and that figure is given over here. So this is the figure. Now here we will find that the wave with the string moves in the upward direction with the velocity va and vb, or in the speed of the wave at the point a and b respectively. That means at the point b the velocity of the wave is vb, and at the point a the velocity of the wave is va, and both these waves are moving in the upward direction. Now we have to find out that the velocity of the wave va and what is the value of VA with respect to VB. Now how to do such problems? Let's see. First what we will do, we'll first see the given data. From the given data it is mentioned over here that in that particular problem it is mentioned that a certain point, like if you just consider this particular point, suppose from this particular point to this particular point, this distance which is given, that is L by 4. And the total length of this particular rod is L. So we can consider the entire length of the rod, and that length is L. And here it is mentioned that this particular distance is L by 4, and another distance, that is from this particular point to this point, this is 3L by 4. So why we know these things, that VA, that is the velocity of the wave at a particular point, we can represent it by TA by mu, and where mu is basically the mass per unit length. Now as it is mentioned in the particular problem that the mass per unit length is m by L, so we can mention that mu is equal to m by L. Now we have to find out TA, the tension, which is basically lies in this particular point. That means the tension at this point will be the lower portions, that means from this particular point A to the point C. If we consider this point is C, that means AC portion. So from A point to C portion, what will be the weight of this length? Now we know that that particular length is L by 4, and mass per unit length is m by L, so multiplied by G. So ultimately it comes down to mg by 4. So that is the tension which basically taking place at the point A. Now once you take about the point B, so we will find in the similar manner Tb by mu, that is the tension at the point B, divided by mu, that is the mass per unit length. Now we can find out the Tb, that is 3L by 4, that will be multiplied by m by L, that is mass per unit length, into G. So we will get a figure like 3 mg by 4. So that will be the tension at the point B. So now we get two equations. One equation is tension at the point A, that is mg by 4, tension at the point B, that is 3 mg by 4. So what we will do with this, now we will just simplify in this manner. So we can write down VA by VB, that is the velocity at the point A and B, is equal to root over of TA by mu and divided by root over of TB by mu. So now we just put this two value, that is mg by 4 and divided by 3 mg by 4. So what we'll get, we'll strike down 4, strike down mg, so it comes down to 1 by root 3. So we can write down over here, that is VA into root 3 is equal to VB. So that is the velocity, that is the at the point A or at the point B. So at the point B, the velocity of the wave, velocity of the wave will be root 3 times that of the velocity of wave. So this is a kind of typical type of problems normally comes in kind of exam like JEE Main and NEET. Thank you very much.